draw the reflection of all the shaded shapes in the mirror line. So this shape here is 1 to the left, so we can shade 1 to the right. This shape here is 3 to the right, so we can shade 3 to the left. And then this shape here is 2 to the left, so we can shade 2 to the right. So that way we have the same reflected on both sides of the mirror line. The London Eye is a big wheel with pods to carry passengers. It takes 30 minutes for the wheel to make a complete turn. This graph shows the height of a pod above the ground as the wheel turns. How long from the start does it take the pod to reach a height of 75 meters? So we have the height of pod above the ground in meters on this side, so we can find 75, draw a line across, and then draw a line down from where it hits the line on our line graph. So we can see that that's between 5 and 10, but it's slightly closer to 10 than it is to 5. So I would estimate 8 minutes to reach a height of 75 meters. Now, how many meters above the ground is the pod at its highest point? So the highest point is this point here, and if we draw a line across, we can see that that's between 125 and 150, but it's slightly closer to 125. So I would estimate 135 meters, but you get the mark for an answer between 130 and 140 meters. Match each fraction to its correct percentage equivalent. So we need to remember that percentages are fractions with a denominator of 100. So first we have 12/50ths. To change that to a percentage, we need to find an equivalent fraction which has a denominator of 100. 50 times 2 is 100 and 12 times 2 is 24. So because 12/50ths is equivalent to 24/100ths, that's the same as 24%. But now we have 12/75. Now 75 is not a factor of 100. We can't multiply 75 by anything, or at least not by a whole number, to get a denominator of 100. But what we can do is simplify the fraction first. Both 12 and 75 are in the 3 times table, so we can divide both the numerator and denominator by 3, and that gives us 4/25. So we've simplified our fraction, and now we can change it into a fraction with a denominator of 100, because 25 times 4 is 100, so if we do the same to the numerator, 4 times 4 is 16, so because 12/75 is equivalent to 16/100ths, that's 16%. So remember, if you can't find the equivalent fraction straight away, you might need to simplify the fraction first. And we'll need to do that again here, because we have 12/40, but 100 is not a multiple of 40. So we need to simplify the fraction first. 4 is a factor of both 24 and 40, so if we divide by 4, divide both the numerator and denominator by 4, that gives us 6/10ths. And if we have tenths, we can change those into hundredths. 10 times 10 is 100, 6 times 10 is 60. So because 24/40 is equivalent to 6/10ths, and that's equivalent to 60/100ths, we know that we need to match this with 60%. Complete the table. So for each shape, we need to write the number of faces, vertices, and edges. First, we have a cuboid, so we need to remember that a cuboid looks like this. Now the faces are the flat bits, and we have 6 faces. Now we need to find the number of vertices, and the vertices are the pointy bits. So we have 4 pointy bits at this end, we have 4 pointy bits at the other end, so that's 8 pointy bits, 8 vertices altogether. Now we need to find the number of edges, and the edges are the lines that connect faces. So we have 4 edges on this end, 4 edges at the other end, and then 4 edges in the middle connecting the corners. So that's 4, 4 and 4, so 12 edges altogether. Now we have a triangular prism. So remember, a prism is like a 2D shape that's been stretched out. So for the number of faces, we have a triangle at both ends, and then we have 3 rectangles in the middle, so that's 5 faces altogether. We have 6 vertices, so 6 pointy bits, 3 at each end, and we need to find the number of edges. So we have 3 edges on this end, 3 edges at the other end, and then 3 edges in the middle connecting the corners of our triangles. So that's 3, 3 and 3, so 9 edges altogether. And finally, we have a square-based pyramid. For the number of faces, we have 1 face at the bottom and then 4 faces connecting each edge of the square to the top of the pyramid. So that's 5 faces altogether. Now for the number of vertices, we have 1 vertex at the top of our pyramid, but we also have 4 vertices along the base. So that's 5 vertices altogether, and then we have 8 edges, because we have 4 edges around our square, and then an edge connecting each of the corners to the top of the pyramid. Calculate the size of angle P in the diagram. So we need to find this angle here. We can see that we have 2 angles that are 50 degrees, and then we have a right angle here because we have a square marked at the angle. So we need to remember that a right angle is 90 degrees. So we can write 90 on our diagram. Now we have angles around a point, and angles around a point add up to 360 degrees. What we mean by angles around a point is that we can take a point, so this point here, and then whatever direction we move in, we get to an angle. So if we move this way, we get to this angle of 50 degrees, move this way, and we get to our right angle, move this way, and we get to an angle of 50, or move this way, and we get to angle P. So that's angles around a point. And because they have to add up to 360, we can subtract the angles that we have from 360. So work out 360 minus 90 minus 50 minus 50. Now when we're subtracting lots of things, sometimes it's easier to add up what we're subtracting. So if we have 50, 90 and 50, that's 190 altogether. And then if we subtract that from 360, we get 170 degrees as angle P. Write the missing digits. So we have a missing digit multiplication, and we can solve this by following the same steps that we use for column multiplication. So remember, we start by multiplying our ones digits. So we have 7 times something, and we have a 5 below. So that means 7 times whatever our digit is ends in a 5. Now 7 times 5 ends in a 5 because 7 times 5 is 35. So we write the first digit of 35 above the next place value along. Then we have 1 times 5, which is 5, plus 3 is 8, and we have an 8 in our answer line. Now onto our hundreds, we have 3 times 5, that's 15, so 1, 5. And then we have something times 5 plus 1 is 11. Now 2 times 5 is 10 plus 1 is 11, so this missing digit here must be a 2. And then we could follow the same steps for our second answer line and check that it works. 2 letters have a total weight of 120 grams. One letter weighs twice as much as the other letter. Write the weight of the heavier letter. So we have 2 letters, one which weighs twice as much as the other. So we can draw a bar twice as big as the other bar. And we know that the total weight is 120. Now our heavier letter is twice the weight, so we can draw 2 bars underneath that and then a bar of the same size for our lighter letter. So we have 3 bars on this line, and that adds up to 120. So to find the value of each bar, we can divide 120 by 3, and that's 40. So we can write 40 in these bars here, and then to work out this bar, we have 40 plus 40, so that's 80. And then the lighter letter will be 40, and that makes sense because 80 plus 40 is 120. So the heavier letter is 80 grams. Jade makes fruit salad. For every 3 apples, she uses 1 banana. She uses 27 apples. How many bananas does she use? So we know that for 3 apples, she will use 1 banana. So we could write this as a ratio, 3 apples to 1 banana. But altogether, she uses 27 apples. So we can think 3 multiplied by what makes 27? Well, 3 times 9 is 27, and if we do the same to the bananas, 1 times 9 is 9, so that means she uses 9 bananas. Write the missing numbers. 30,000 is 1,000 more than what number? So this number here will need to be 1,000 less than 30,000, and 30,000 minus 1,000 is 29,000, because 30 minus 1 is 29, and then we don't have any hundreds, tens or ones, and we're not subtracting any hundreds, tens or ones. So our answer is 29,000. Now, which number is 10,000 less than 300,000? So we want a number that's less, which means we need to subtract 10,000 from 300,000. And 300,000 minus 10,000 is 290,000, because 30 minus 1 is 29, but then we have zeros in our thousands, hundreds, tens and ones, and we're not subtracting any thousands, hundreds, tens or ones, so we have zeros as those digits of our answer, 290,000. Now this question can look a bit confusing, because on this first question we have the larger number on the left and the smaller number on the right, and for this bottom question we have the smaller number on the left and the larger number on the right. But the reason for that is because this first question says more, but this second question says less. Write the 2 missing values to make these equivalent fractions correct. So we have 17 fifths, and we can see that we need to find an equivalent number of tenths and change it to a mixed number as well. First, let's find out 17 fifths is equivalent to how many tenths. To find equivalent fractions, we use multiplication. 5 times 2 is 10, so if we do the same to the numerator, 17 times 2 is 34, and we might need to use short multiplication for 17 times 2, but we get 34 tenths. Now we need to change 17 fifths to a mixed number. The denominator stays the same, so that will be 5, and then we need to remember that a fraction is really a division. So if we divide 17 by 5, that gives us 3 remainder 2, because 3 times 5 is 15, and then we need 2 more to get to 17. So that's 3 and 2 fifths. The 3 is our whole number, and then the remainder is our numerator. So we have 3 and 2 fifths.